How do you stop your AI from lying to your users? And how do you prove that your application is actually ready for production? Let's learn with the Coder Therapist.
Hey, don't worry. I'm right here by your side, ready to help you achieve your dreams of becoming a software architect. In our last session, we built a RAG pipeline. It felt like magic. But here is the hard truth. Anyone can follow a tutorial to build a prototype. To become a true software architect, you must ensure that system is reliable, factual, and safe. Today, we are going to move from "it works on my machine" to "it works in production" by mastering RAG evaluation. Let's learn and grow together.
To become a software architect, you need to understand where things break. Inside software architecture, we're going to learn the two specific ways your RAG system can fail. First, let me show you the explanation along with a diagram to help you understand these failure points.
The first failure is retrieval failure. You can think of it like a librarian who simply can't find the book you asked for. If a user asks about refund policies, but the retrieval layer pulls up documents about shipping labels, the AI doesn't stand a chance. It's not confused, it just doesn't have the right context.
The second failure is generation failure, often called hallucination. This is when the librarian gives the student the correct book, but the student ignores it and writes whatever they want. The context was perfect, but the AI still decided to make up an answer. And as an architect, you must measure these two problems separately. So, how do we measure all of this without reading thousands of logs by hand? We use a framework called RAGAs. Think of RAGAs like an automated professor grading exams 24/7. It uses a separate language model. This is the brain of the evaluation to check the work of your main application. And now, we're going to dive into the technical side and focus on gaining hands-on experience with two specific metrics. The first metric is faithfulness. This measures the generation layer, and it asks a very simple but critical question. Is the answer derived only from the retrieved context? Think of faithfulness like this. Did the student stay inside the boundaries of the textbook? Now, the second metric is context recall. This measures the retrieval layer, and it asks another critical question. Did we find all the information needed to answer the question? If the answer exists in your database, but your retrieval system fails to pull it in, your recall score drops. So really take the time to understand these two metrics. They're not just numbers, they're your dashboard for quality. Now let's look at the code. To build an evaluation pipeline like this, you first need to get comfortable with generating a test set. Because here's the reality. You can't evaluate your system if you don't have real questions and answers to test it against. And writing hundreds of test questions by hand, that's slow, painful, and completely impractical. Here's how everything works together. We use a language model to look at your documents and automatically generate test questions for us. It creates a test dataset that includes three things: the question, the ground truth answer, and the exact context chunks those answers come from. Once we have this test set, we run our RAG application against it, using the evaluation function. This is how we test the system in a controlled, repeatable way, and finally, understand how well it's really performing. When you run this evaluation, you get a scoreboard. And this is where your real problem-solving skills start to matter. This is where you learn to make tough trade-offs, like an architect. If your context recall score is low, your retrieval is failing. That usually means you need to rethink your chunk size. If chunks are too small, they lose meaning. If they're too large, they confuse the vector search. Now, if your faithfulness score is low, your language model is hallucinating. In that case, you need to tighten your system prompt. Be stricter. Tell the model clearly, if the answer is not in the provided context, say, "I don't know." Think of this scoreboard as your control center. You stop guessing, and you start engineering. Moving from a junior developer to a software architect isn't just about writing more code. It's about confidence. When you can sit with a stakeholder and say, "Our system is 92% faithful to the source material, and here's the data to prove it," you're no longer just coding, you're architecting trust. And this is where soft skills matter. Use these metrics to communicate clearly, to explain risk, to align your team. That combination, technical depth and clear communication, is what turns engineers into architects. You now have the tools to audit your own AI systems. All that's left is to take the step and implement them. Thanks for watching The Coder Therapist. If this helped you, don't forget to like and subscribe for more updates. Let's learn, grow, together.